Hello students, I hope you all are doing good. So today we will see the next part of our relation functions, that is functions. You have done your Cartesian product, you have done your relations, and now you're going to do with the functions. So what is function? You have seen in relation, and see, this is also a very quite important topic. Your Cartesian is linked with your relation is linked with function. Taking this only you have to do. So function, you can tell it a special type of relation it is, okay? It is a special type of relation. Now in your relations, I had showed you R1 from A to B. Yes, you had full 1, 3, 1, 4, somewhat like this you had, right? And then you had one more R2 where I had given you x comma y such that y is greater than x. Yes, for all x belongs to A, y belongs to again B. So you had such questions in your Cartesian. Now function, what it tells, function is bit different from your relation. In your relation, I'll show you in this diagrammatic. Suppose you have A, you have B, okay? So 1, 2, 3, 4, 5, 6. So one relation you had, like 1 was linked to 4, even mapping, you call this as a mapping. This arrow mark you call in your function, you call it as mapping. Even 1 is image, 6 is image of 1, 2 for 4, 5, 6, 3, 4, 5, 6. Okay, this was your Cartesian with your relation. But in your function it tells every element of set A should have only one image in set B. Means, now this is set A, this is set B, 1, 2, 3, same I am writing, 4, 5, 6. What function tells every element in set A should have one and only one image in set B. Here you see it has, in this sets it had 3 images. Just one, it had 4 also, it had 5, it had 6. It was mapped with 4, it was mapped with 5, it was mapped with 6. So such we don't call it as a function. Such sets we don't call it as a function, or such relation we don't call it as a function. Now if 1 is mapped to 4, 2 is mapped to 5, 3 is mapped to 6. This is called as a function, where every element of A should be having only one and one image. If you have, not necessary, it should be in a straight only. If 1 is mapped to 6, 2 is mapped to 4, 3 is mapped to 5. Even this is okay, because ours is only linked with what? Every element of this should have only one image. You can see 1 is mapped only with 6, so it has only one image. 2 is mapped with 4, it has only one image. 3 is mapped with 5, it has only one image. So we are not concerned whether to which numbers or it is side, upside, however it is mapped. We are not concerned of that. We are just concerned that every element in set A should have only one image in set B. That is what your function tells. Okay. So we'll see the definitions and all. I'll write it. Just pause the video and note it down. So what I have explained you, I have written all the definitions. So please pause it to write it down. Relation function. Then here you can see B is called image of A and A is called pre-image of B under F. Yes, you have. I have explained you in your relation also. Function, same definition in other words also. So it is telling F is a relation from a non-empty set A to an empty set B such that domain of F is A. Means its domain, what I had said, every element of A, it will be that only, right? A. And no two distinct ordered pairs in F have the same first element. Means in this elements you shouldn't have your one element only should not be the image of 2, like 1 is to 4 and 1 for 5 also mapping. What I've explained you, that only in one more definition way. Either you can do that or this, but write both the definitions. For example, I have given you the same A, B, and I've given you this one condition 1, 4, 2, 5. So how you write function A to B? You give it like this, okay? From A to B, you understand. So domain, see what it tells, domain of F is A. So when we tell here its domain will be what? 1, 2, 3 only, right? 1, 2, 3. 1, 2, 3 is set A only. So domain you got 1, 2, 3, which is A only. However you do domain, you get A only. And they're telling no distinct ordered pairs in F have the same first element. So you see here 1 is mapped with 4, 2 is mapped with 3. 5, 3 is mapped with 6. So it is not mapped with the same element. So condition also satisfied. Second condition also satisfied. So what it means is the same, in other words. One more note you have. You have your note. See, in a function, your one element, as I said, you one element shouldn't have more than one image, because this is not possible. But your other two elements can have only one image. This is possible. Because see, in your definition they have said every element of A should have only one and only one image. They have not said that every element of B also should have only one preimage. Okay, go with the definition properly. They have said only every element of A should have only one image. So if you consider here, suppose if it is A means, and here if you have C, A has image C, and here if it is B means B has C. Okay, this is possible, but this is not possible, so take it down in a note. Secondly, now we will see visualizing function. Visualizing function itself, like function has a rule, like what it is a rule that gives new element out of some given element. For example, now suppose my function f of x is equal to, there is 2x. This we tell function only, okay, function, how we tell f of x. This function is equal to 2x. And now you see here, if I give x is equal to 1, f of x, what I'll get? 2 into 1, in place of x I have to put 1, now this will be f of 1. So f of 1, what I'll get? I'll get 2, right? This you can take it as a y also. Y is equal to f of x. Now if I put x is equal to 2, my f of 2 will be what? 2 into 2 is 4. If I give x is equal to 3, my f of 3 will be what? 6. If I give x is equal to 4, my f of 4 will be what? 8. So see, it is telling what? A rule that gives new element out of some given element. So this is already a given element. So whenever you are putting the numbers, you are getting one more new elements. Okay. So this is a rule. This is also, we call it a function. Now if you see here, if I write in an ordered pair, 1 I am getting 2, 2 I am getting 4, 3 I am getting 6, 4 I am getting 8, like this, so on. You can get it anyhow, because here they have not given. Now if I take here 1, 2, 3, 4, 5, 6, however it is, here 1, this A, this B, if I consider, here also 1, 2, 3, 4, 5, 6. See, 1 you are getting image 2. For 2 you are getting image 4. For 3 you are getting image 6. For 4 you get image 8. So here you can see every element of your A will get one or the other image. Yes, one or the other image. So this is called as a rule, as a visualization. Here you can see this 1, 2, 3. These are natural numbers only, right? So you can tell, and even here also it is 1, 2, 3 natural numbers. So function from n to n is function from n to n, same numbers, natural numbers to natural numbers, and your condition is what? 2x. Your rule they have given 2x. So this is a function, you can tell. This is a function. By seeing this only, how you can tell function? Because for 1 you will get 2, for 2 you will get 3, for 3 you will get 6. So for every element you are getting a unique image. You are getting only one image. Okay. So like this it is. Now suppose if I take f from R to R, R means what? My real numbers, right? We have gone through what is our real numbers means. It includes our natural, whole numbers, yes, rational numbers, except your irrational, integers, everything. Now here if I give f of x equal to condition as x square minus 1 whole divided by 2x, if you take this as a condition. So here by seeing this only, I'll tell this won't be a function. Why this won't be a function? See, suppose if I put x as a 0, okay, so this will be what? At x is equal to 0, if I am putting the value at x is equal to 0, so I get 0 minus 1 whole divided by 2 into 0 is 0. So here I will be left with 1 minus 1 by 0. So minus 1 by 0, it is not defined only, right? You don't have only any value for this. We call it as a infinity. If you know it, we call it as a infinity, and infinity there is nothing defined. So whenever you write, if you write 1 from negative also, you consider minus 2, minus 3, minus 2, because real numbers you will be having negative also, positive also, right? 1, 2, 3 and all. For here we are writing for 1, 3, 4, for everything you are getting image, but for 0 you don't get only anything. There is no image only for 0, right? For 0 you don't get only, so you can't tell this is a function, right? You can't tell this is a function. But if I write this question only, how? F R minus 0 to R. What it means? Real numbers except 0. I am subtracting 0 from every real numbers, from this to this, from this real number. So then just if you remove 0 means rest all numbers you will be having images, then you can tell at this, then you can tell this is a function. Understanding? Whatever function, whatever rules for some, in our real valued function, what it means? Real valued function means your one element new, it gives one more new element. So how you have to find means, they'll give you a function, in that you have to substitute the numbers for x and you have to find f of x, whatever you get, and you have to place it, make it a images. Okay. So what I explained you, real valued function, the same definition, a function which has either R or one of its subsets as its range is called a real valued function. For example, like I said, you f from n to n is natural numbers to natural numbers only because whatever you're putting, you're getting its subsets. I mean, whatever you're getting the answer, it is the subset of its domain itself. Okay. So function, what they have given, 2x plus 1. So see, of a table, how I said you same, x, y, you can take this f of x as y also, your whole, or you can write f of 1, f of 2. So when x is 1, when I'm putting here 1, this what I'll get, 2 into 1 is 2 plus 1, I'll get 3, f of 1 will be 3. When it is 2, I'll get 5. When it is 3, I get 7, like this on, you can get it. What I explained you just in your definition form. Please pause it down to write the notes. So next you have some functions and their graphs. You have some functions and their graphically also we'll see. So you have studied of your in terms of arrow, in terms of your roster, in terms of your set builder. In the same way, in your function is always represented in terms of your graph. Okay, your function is represented in terms of your graph. Okay. So your first function we are telling identity function. See the term identity only can tell it. Identity means what? Identical. Identical means same. Whatever you give, you get the same. So now suppose your function f of x is equal to, you're getting as x. So you see whatever value of x you put, your y you'll get as same x value. If you put x is equal to 1, your f of 1, y which is equal to, it will be 1 only. If you put x is equal to 2, y which is f of 2, you'll get 2. So whatever you put x value, you'll get the same. So that is called your identical function. Okay. Graphically, if you see means, I have drawn your graphs here. This is the definition in definition wise. So pause it to write it down. Now if I go graphically, so if I take 0, that will be 0. If a 1, this will be 1. If I take 2, y will be 2. Y axis, I have taken it as f of x. If I put x as 3, your y again you'll get 3, y 4, 4. So like this, in the same way you'll get a straight line, right? So you can see for identity function, you'll get it as a straight line. So here when you when you do the function, its domain and range will be R itself. R means what? Our real numbers, right? This is a real number plotting. Yes, real numbers includes everything, so it comes in a graph. So here domain and your range you'll get the same. If see here x, whatever you'll get, f of x also you'll get the same answer, right? So whatever you'll get the range. Now if I give here 1 means 1 you'll get. If I put here 2 means 2 you're getting. So your domain 1, 2, 3 only you'll get, and your range also 1, 2, 3. So everything, your domain and range is your real number itself. Second is your constant function. Constant means what? Word constant only you know means it is fixed. Constant means what? Fixed term, right? Constant means fixed. So now if they are given you number, like suppose f of x is equal to c, they have said. Okay, c I have taken as a constant any. Now if I put x as 1, x is equal to 1, suppose you c consider it as let c will be 3 or 2, whatever. Okay, you're getting f of x as 2 only, x value whatever you put. If you put x is equal to 1, f of 1 you get 3. If you put x is equal to 2, f of 2 you'll get 3. So whatever values of x you put, your f of x you'll get the same value, that fixed value, which is termed as constant function. So how your graph will be? If you see in a graph base, you have written the same. Suppose here your c is equal to 2 I am taking. Okay, your c I am taking constant as a 2. So when it is when x is 0, it is 2. When x is 1, y is 2. When x is 2, again y is 2. When x is 3, same, because you are getting the constant term. Even minus 1, 2, and you have minus 2, 2. So you will get a straight line. So you can see you will get a line, but which is parallel to x-axis. You tell it parallel, right? They go sidewise. Okay. So in this, your domain, f domain will be what? Your R real number, but range will be only one term, right? Because whatever, for example, if it is 1, you are getting 2. If it is 2, you are getting 2 only. If it is 3, you are getting 2. So your 1, 2, this is your domain, and range are getting same. So range will be whatever the constant term is. Okay. So next is your polynomial function. Everyone knows what a polynomial function means. It is defined as how a0 plus a1x plus a2x square plus a3x cube, so on up to till our nth term, right? Where your n is your non-negative integer and a0, a1 all belongs to real numbers. Real numbers, you know, it includes your both positive, negative. In your polynomial, see, it doesn't have a fixed graph for this, because polynomial function, it can be in anyhow. It is x square. Now suppose I've taken here x square. Polynomial, you can have like this also, right? 2x plus 1. You can have x cube. You can have x square plus 2x, these all are polynomial, right? So for every function there will be particularly different graphs. So seeing the question, you should understand the graph so that you shouldn't what you tell by heart what the graph is. Suppose now I have taken f of x as x square, means this your y axis as your f of x, and now if I put here x as 1, your x square f of x will be 1 square only. If I put x as 2, my f of x will be 4, 3 if it will be 9. Same, minus 1 square will be 1 itself, minus 2, if my x is minus 2, its square will be 4 only, right? Because negative minus 2 whole square. Negative also if you do square, you get in a positive only. Minus 1 into minus 1 is plus 1, right? Minus 1 into minus 1 is plus 1 only. So if you go in a negative also, you will get a positive only. So here your graph will be like this, you will get kind of, you call it as a parabola. You have not studied yet, but this graph is said as parabola. You call it as a parabola. For x square it will be always parabola. So here you see your domain will be your real numbers only. Yes, because it will be 1. For 1 you are getting 1, for 2 you are getting 4, for 3 you are getting 9, like this. So your domain, it will be real numbers, yes, but your range will be what? It will be only r plus, only positive terms, not negative. Yes. Next you have rational functions. You have studied only rational functions, how it will be in the form of p by q, right? So you have written type f of x by g of x only, where your g of x should not be equal to 0, right? Your denominator should not be equal to 0. You have studied about this. Now see in your rational functions, this also doesn't have a particular graph for this. So this graph is not important, but simply just for one question, if I take f of x equal to 1 by x, okay? If you take like this, if you do anyhow, the graph, right, you get in such a way. Like this, this should be straight, okay? Like this, you'll get a graph. Like this you can see. Here you see as your 0, for 0 nothing you have. So in your real numbers except 0 you are telling. Why? Because if you take here 0 as x is equal to 0, if you take, you will get infinity, which is not defined. So you have to write real numbers except 0 in this. Here you can see when you take 1, it will be, when it is here 1, x axis, y also will be 1. But in between your 0 and 1, you can see your graph is just increasing and increasing, means it is infinitely, it is going on, but it never touches your 0, means it is infinity. And greater than your 1 means like 2, 3, here also it is tending towards 0, but it will never be a 0. Even in your negative side, you can see for 0 it is 0, for minus 1, here it will be minus 1 only. So between minus 1 and 0, you can see it is heading, it is going on increasing, but it is never tending to infinity. Yes, it is never equal to infinity, but it is closer to it. And less than this minus 1, minus 2, if you go, this is heading towards 0, but this will be not equal to never 0. So in this, your domain will be what? Real numbers only except 0. Even your range also will be the same. Okay. Next is your modulus function. A function f from r to r defined by f of x equal to, say this term is called as modulus, like this 2 bar you have to put inside x. Modulus x for each x belongs to r is called modulus function. Okay. This modulus function, in your modulus means you will be having positive, negative. It breaks into 2. Like here I am breaking it. See, when it is telling it is greater than or equal to 0 means this is positive, right? Greater than, if you tell, means obvious it comes under positive only. When it is positive or equal to 0, you will get x only, and you will get in a positive answer. If it is less than 0, which means it is negative, you will get in a negative. Okay, your x will be minus x, and first of all your x will be negative, again negative they have added and make it as a positive. So in your modulus, if you get negative term also here, the answer you will get whole f of x in a positive only. For example, now see here, if I take f of 2, okay, x is 2 means mod 2, this is greater than 0. Yes, it is greater than 0, it should be what? Positive x only. X is what? 2, so I will get here 2. F of mod 2 is 2. Now if I suppose if I take this f of minus 2, so this is mod of minus 2. So when your x is negative, what we will get? Minus of x means minus 1 already, and your x is what here? Minus 2. So this minus becomes plus, again it makes positive. So if you have a negative term also, it makes it a positive. So this modulus how we break it. Okay. If we go in a graphical way, we'll see. So first, when you take this definition, when f of x equal to x means x is greater than or equal to 0. Now suppose f of 1 if I take, 1 is greater than 0 only, right? Yes? It is not visible. Okay. F of 1 is greater than 0 only. So when you take f of 1, you will get 1 only because x. So when it is 1, it is 1. Same, when it is 2, you will get 2. When it is 3, you will get 3. Like this, you will get a straight line. Same way, for next condition, when it is less than 0 means your f of x is equal to minus 1. If it is minus 1, you will get minus of x, which means this minus sign, okay, and x term is what, minus 1. So minus of minus, again you'll get plus 1 only, right? So when it is minus 1, you'll get plus 1. When it is minus 2, you'll get plus 2. When it is minus 3, you'll get plus 3. So in short, your graph will be like this, okay. Your modulus for your negative also, it makes positive by how? By adding a negative sign, okay. So be careful in this modulus part, it is very important. Now see here, f of x equal to mod x plus 2. How to break it? Yes, how to break this function? Now I have shown you how it was. F of x equal to, when x is greater than equal to 0 means positive. Your x will be positive, right? Here x function is what? X plus 2. Okay, it is x plus 2. Is it clear or no? Just a sec. Okay, so how we break it? As I said you, first for positive and equal to 0. For positive equal to 0, it will be x only, right? So your x is what here? X plus 2. When it is less than 0 means negative sign. When it is negative means already when negative and you are writing your x value, that is x plus 2. Like this you have to break your mod, whatever mod function is, you have to break it in such a way. One will be x equal to 0. See, your equal to sign, it will just come to at one place, not on two places. Yeah. So like this you have to break it. Next is our signum function. So what is our signum function? Signum function, see, like this conditions they'll give. One is mod x by x when x is not equal to 0, 0 when x is equal to 0. When it is not equal to 0 means it should be greater than and it will be less than. So when it is greater than 0, your mod x again we will break. Yes, mod x we will break into, when it is greater than means this will be x. Denominator remains as it is x only. So x 1 you get as 1. When x is equal to 0, when it is 0, what they have said? They have said already it is 0. So when it is less than 0, when it is less than 0 means your mod x will be what? Minus x, right? And your denominator to x, keep it as it is. So x 1 but you have minus sign, so you get minus 1. So in short, your signum, how they are writing? X when x is greater than 0, 0 when x is equal to 0, minus 1 when x is less than 0. So this is called as your signum function where we break it out, okay. When you see the graph also of this, if you're going to see the graph too, you see here, when x is equal to 0, it is 0 only, okay. When x is equal to 0, it is 0. But when x is greater than 0, means greater than 0 means it can be 1, it can be 2, it can be 3, whatever. And it means positive sides it will be, right? Greater than means full positive. Your value will be what? 1 only. If you get 1, your value will be 1 only. If x is 2, it will be again 2. If it is 3, means you will get in such a way. Here, the line will be ending up to the positive side. When it is greater than 0, your y values, that is your f of x, you'll get 1 only. Same when it is less than 0. Less than 0 means negative side, right? Minus 1, minus 2 this side. Negative side, your f of x will be what? Minus 1. So when it is minus 1, it will be minus 1 only. When it is minus 2, say minus 1 only. When it is minus 3, you'll get minus 1 only. So here it will be going in this way. So you can see when it is less than 0, when it is negative side, it will be just one thing constant, and when it is positive, it will be constant 1 only. When it is greater than, you have 1 only constant. As 0, so it is 0. When it is less than 0, it will be one more constant term, okay. If you see its domain, so it gives real numbers only. Range, it will give only 3 numbers, that is only one set, that is minus 1, 0, 1. Yes, you see only minus 1, 0 and 1, this only it gives the range. Range is our all x-axis, right? And our domain is our range is our all y-axis and our domain is our x-axis, okay. Next we see our greatest integer. Next is your greatest integer function. So your greatest integer function, what it tells, it is denoted like this: f of x equal to bracket x, okay. It is bracket x, as I have written, f of x bracket x. It is telling the value of greatest integer less than or equal to x. Its definition is what? It is the greatest integer which is less than or equal to x. Now this you are not understanding, suppose, okay. I'll just break it down into two sentences. When you see integer less than or equal to x, means I can write it like this. Just I'm writing integer less than or equal to x, it is telling, okay. Integer is less than or equal to x. So now you see here it is a 2.1, okay. So if I write here 2.1, okay, this less than or equal to x, x is 2.1 only, less than this terms are what? 2. Then you have 1, you have 0, you have minus 1, you have minus 2, minus 3, so many you have. In this now, which number you have to take? Is in this, which will be your greatest integer? For that, here they have given you greatest. So in this, which is the greatest? It is 2. So f of x of 2.1 greatest integer is what? 2. Understood how you have to do? In the same way, now you see a 4.9. So less than or equal to 4.9 will be what? You have 4, you have 3, you have 2, you have 1, 0, so many. But greatest, they are telling, greatest is which? 4. So its greatest integer 4.9 will be 4. In the same way, minus 3.2. less than this 3.2, you have minus 3, you have minus 2, you have minus 1, you have 0, 1, 2, so on. Greatest, they are telling greatest is which? Minus 3. So minus 3.2 greatest integer will be 3, right? So when you have now 5 integer less than or equal to 5 means 5 will come only equal to, and again less than that is what? 4, 3, 2. But they are telling greatest, so greatest will be what? 5 itself, right? So whenever you have your whole number, here one kind of trick, whenever you have a whole number, whatever they give 5, 6, 1, 2, if it is a whole number, your greatest integer will be same, whatever the number is same. Now if it is 5 means 5, if it is 4, 4, 3, 3. But when it is in a point, okay, when it is in a point, so less than this number will be your greatest integer. 2.1 it is 2, 4.9 see it is 4, 3.2 it is 3, understood? If it is 3.1 also it will be 3 itself. If it is a 5.6 then the greatest integer will be 5. So you should do like that, or else one more method is, see now 2.1, you can see two numbers you have to take, it should be less than or equal to x. So your 2.1, it is lying between, less than term is 2 and greater than this you can take 3, whole numbers only you can take, okay, you can take this because they are telling integer, either if it is in a point also means here it will come an integer but in a whole number. So 2.1 less than this, less than or equal to, it will be 2 only, greater than that 3, one term. So in this is lying between 2 and 3, but greatest term will be 2. You can go in such a way and you can write 2. Even 4.9 you can see it is lying between 5 and it is lying in between 4. Between 4 and 5 you are getting 4.9. If you take number line like this, now 4.9, here this is 4, here it is 5. Your 4.9 lies here in between this both, but its greater integer will be what? It will be 4. Why? They are telling less than this is, it is 4. Same way you can do in a number line if you are not understanding in such a way. 3.2 means lie between 3 and 4. This 3.2 lies between 3 and 4, right? But it's greater, it is approaching, less than is what? 3. You can do in such a way also, okay? 5 to 5 only because equal to also they have said. So these are the some functions. Please pause the video to note it down and make your notes. Thank you. It's graph, forgot to tell you. See graph, when it is 0, 0.9, suppose if it is 0.9, so 0.9 greatest integer will be what? 0 itself, right? So it will be lying, you can 0.9, 0.1, 0.2, whatever, everything lies between your 0 and 1, yes, so it will be here. When it is 1, f of 1, your greatest integer of 1 will be what? 1 itself, right? So slightly it jump near 1. Again from 1.1, 1.2, it will be lying between this. And again it is 2 means it gets here jump, yes. For your 2, again it becomes 2 and again between this it will be lying. So like this it will be slightly jumping and like this you'll get a kind of staircase. Same here, from this 0 point you'll get here 0 itself, it will be lying here. But for minus 1 it will jump and minus 1, minus 2 it will be lying. Again for minus 2 it jumps and here it will be lying between for 3. So like this you'll get a staircase, okay. Thank you.